Okay, just let me remind you, my name is Ron Bannon. My email address is Bannon. That's if you see something wrong in my document, please let me know, all right? Now, certainly I've been saying some things that may or may not be obvious, but I want to go through it with you, all right? I'm going to go to the whiteboard, and we'll take a little side journey here. I'll get back to the problem momentarily. So let's erase this business over here. And I was talking about, you know, 3 consecutive integers being divisible by 3 factorial. So, you know, n plus 1, n plus 2. I said that this was divisible by 3 factorial. And, you know, n plus 1, n plus 2, n plus 3, that's 4 consecutive integers. That's divisible by 4 factorial, so forth and so on. And what I'd like to do is just justify that, all right? So I'm going to put down n, k. These are binomial coefficients. What does this equal? N factorial. And what goes on bottom? K factorial over n minus k factorial. And this is an integer. All right? So what I want to do is just, you know, what does this look like? N minus 1, n minus 2, yada, yada, yada. And I'm going to put down, let's see, and well, let's put the bottom down first so we know exactly what goes there. So it's going to be k factorial, and then, you know, n minus k factorial here. So it's going to be n minus k plus 1, and then n minus k factorial. This would cancel off. Now someone says, what are these things over here? They're consecutive integers, right? How many are there? There's k, all right? If you count them up, you get k of those, all right? So that's why I'm saying this over here. And this is a nice fact to know that, you know, like if I put this over here, n plus 1, n plus 2, n plus 3, and these are consecutive, n plus 4. And you could do it differently. What have that? 1, 2, 3, 4, 5. Sorry about that. This is divisible by 5 factorial. All right, let's just do another one. Let's say I started with, you know, n, but instead of going up, I go down. N minus 1, n minus 2, n minus 3, n minus 4. This is divisible by 5 factorial. All right? So what is it? 5 consecutive integers. 5 consecutive integers. And you could do that for 6 or 7 or 8 or 9 or 10, so forth and so on. Where are we getting that from? Binomial coefficients. They're integers. All right? Let's go back to the problem and let's look at it. All right? Now it's related to this over here. So what I want to do is go to the whiteboard again and do the problem. It says prove that this thing is a multiple of 6. All right, so I'm going to go to the whiteboard. Give me 1 second to do so. Again, I have to get back there. Let me push this up. And let's write down what they have. And I gotta get the problem on my other computer because I can't see it. Or I shouldn't say I can't see it. I can't remember the problem. So let's write this down. They want me to prove that n times n plus 1 times n plus 5 is a multiple of 6. To be a multiple of 6 means it's going to divide by 6. So let's write this down. What do we get over here? N. I'll put an equal sign down. Sorry about that. N plus 1. Let's see. N plus 2 plus 3. All right, let's keep going. What do you get over here? N plus 1, n plus 2, plus, what do you get there? You'd get n plus 1 times 3. That seems strange, but it's something I'm looking for. And what is going to be n plus 1, n plus 2, plus 3n, n plus 1. Okay, multiple of 6. That means that this divides by 6. Well, let's do one at a time. And what's this over here? N plus 1, n plus 2. And what's 6? It's really 3 factorial. So that's a guaranteed divisibility there. Let's look at the next one now. It's 3 n plus 1 over 6. Again, this one divides through. We just went through that explanation of binomial coefficients. This one over here, a little strange looking though, isn't it? But here's the deal over here. 3 cancels a 3. There's a 2. And, even odd, it's got to be. It's got to be divided by 2. So this is shown to be true. It's a multiple of 6. Thank you.